Okay, here we have a fairly standard question. We're asked to find dy by dx and the second derivative of y with respect to x at a particular point if we have x and y defined in terms of a parameter t. So it's a parametric differentiation question. Okay, so how do we go about this? Well, really it's an application of the composite rule of the chain rule. We want dy by dx. And what do we have? We've got y in terms of t, so we can find dy by dt. And we've got x in terms of t. So I suppose if we're going to use the chain rule, then we should, to balance up this, have a dt by dx there. And then the chain rule works in that particular example. But we've got x in terms of t, so we can rewrite this as dy dt divided by dx over dt. When you divide by a fraction, it's the same as flipping the thing over and multiplying it by. So we'll flip the dx over dt over multiplied by there. Okay, so that's straightforward enough. If we want to find dy by dx, we find the derivative of y with respect to t, derivative of x with respect to t, and we divide one by the other. Okay, so let's do that. Dx by dt will be 2t, it's fairly straightforward. Dy by dt will be, from up here, it's 6t squared minus 1. Okay, so that means that dy by dx will be 6t squared minus 1 divided by 2t. So that's dy by dx. If we want to find it at that particular point, well, this point is x equals 3 and y is equal to 0. But we've got a derivative in terms of t, so we really need to find out what value of t solves for this point. So what we're trying to find is when x is equal to 3. So we're solving two equations. 3 equals t squared plus 3, or t squared equals 0. Now it's fairly obvious what the solution of that is. T equals 0. And if you take t as 0 and put it into the equation for y, you'll find that you get y is equal to 0. So that's the point at which we're trying to find dy by dx. So dy by dx when t is equal to 0 is, what is it? Well, it's a bad example, I suppose, because it ends up with minus 1 over 0. It's undefined. A bad example, but you get the idea of how to work out the derivative. I should do a better example, but I'll just leave it with this one at the moment. The second thing, to find the second derivative. Well, the second derivative of y with respect to x is d by dx of the first derivative. And we've got the first derivative here, but the first derivative is in terms of t. So we can only really differentiate this thing in terms of t. So again, it's the chain rule. We can't differentiate in terms of x, so we differentiate in terms of t. And then what we must do is multiply by dt by dx. And multiplying by dt by dx is the same as dividing by dx over dt. So we've got this same sort of divide by dx by dt as we had up here. Okay, so let's give that a go. We want to differentiate dx by dt. Well, that expression there is a quotient rule, so let's just do the quotient rule. The thing on the top will be 6t squared minus 1, so du by dt will be 12t. The thing on the bottom will be 2t, therefore dv by dt will be 2. Therefore, I don't know if this is going to fit on here, d2y dx squared will be the derivative of that. Right, so that's v du dt, so it'll be 2t times 12t squared. Sorry, 2t times 12t will be 24t squared minus dv by dt times u, so that would be 2 times 6t squared, which is 12t squared, and 2 times minus 1, but remember we're subtracting all of this, so the net effect of that will be a plus 2, all divided by v squared, which will be 4t squared, square of that. We have to remember to divide by dx by dt, so we're dividing by 2t again. And if we work all that out, what do we have on the top? We'll have 12t squared plus 2 divided by 4t squared and 2t, which will give us 8t cubed. And again, we're asked to work that out when t is 0, and again it's going to be undefined. It was a bad example to choose, but you get the drift, you get the idea of how to solve, hopefully you get the idea of how to solve and how to find derivatives when the equations are given parametrically.